All right, so now let's go into some of our sorting algorithms. Okay, so in one of our sorting algorithms, bubble sort, right? Well, I'll just do it generally. I mean, we know all how bubble sort works. You get the bubble, you run it through, right? And each time you run it through, a new one's in the right position, okay? And so if we're going, in the worst case, we're going n times, and we're doing that n times. We're running the bubble through n, and we're doing that n times, right? So the first time we're running through n, the next time we're running through part of n, the third time we're running through part of n, the fourth time we're running through part of n. So it's all based on n. So you could say for 0 to n, okay? And then inside you could say for, if you call this I, right, for 0 to n minus I, okay? But we know, we've seen this trick before, right? So that's still going to be n times n minus I, right? It's the same thing as n plus m or whatever, right? It's going to be O of n squared, all right? So bubble sort is O of n squared, all right? This is bubble sort, okay? Meaning, as the number of things we have to sort increases, the amount of the runtime, right, is going to increase by O of n squared, all right? Squared, all right? So not a great relationship, okay? And that's why bubble sort, though it's an easy algorithm, and one of our first sorting algorithms we learned, is not typically used, okay? Unless people are just kind of doing a toy problem. Same thing with selection sort. All right, in its worst case, what do we do? Well, it's kind of a similar deal, right? Every time I go through, I have another one that's in the right position, okay? So I have to go through all of them, and I find the first one in the right position, and I go through all of them, and I find the second one, first one in the right position, I mean the lowest. So I find the let's just do, can you explain the algorithm correctly, Shoke? So I find the lowest of all of them, and I put it here, and then I find the lowest of the rest of them, and I put it here, and I find the lowest of the rest of them, and I put it here, right? So each time we're doing another one, and we could play this game again, like the first time we're going from 0 to n, right? So this one, then this one, then this one, then this one, right? And here we're going, if this is I, we're going for I to n, right? And so, or another way to say this is we're going n minus I times, right? And so we have n times n minus I, right? None of that matters. It's still O of n squared, right? Because n times n is going to be n squared, and I times n doesn't matter because it's just we're taking the order of the equation, so it's O of n squared. Okay? Hopefully that makes sense. If that doesn't make sense, I went through it maybe a little fast. Let's talk about it. But you can kind of see it has all the hallmarks of our O of n squared thing, right? We're going to, in a worst case scenario, we're looking through and we're doing n things n times. Okay. All right, let's look at selection sort. That's a little more interesting.